In this lecture, we're going to cover electric and gravitational fields. In the chapter on electric charge and force, the similarity between the electric force and the gravitational force was noted. There is a similar relationship between the electric field and the gravitational field. The reason for this is that the two forces are both central forces and that they act along the line connecting objects. There is a key difference, however, between the two fields and the forces. Mass, which is a source of gravitational field, is always positive, and the force is always attractive. The gravitational field points towards the mass generating it. Charge, the source of the electric field, can be negative or positive, and the force is either attractive or repulsive. Thus, the direction of the electric field points away from a positive charge and towards a negative charge. Given that a mass m is located at the surface of the planet with a mass of capital M and radius capital R, Newton's law of gravitation is used to determine the gravitational force, F sub g, between the planet and the mass, lowercase m. If we divide this expression by the mass of the object, similar to what was done with the small positive test charge Q, and call this little g, the gravitational field, we can see we end up with G is equal to capital G, capital M over R squared. Remember that capital G is 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. This is used to express the weight of the mass M on the planet. Remember that weight is equal to mg. So here's a chart that shows the gravity and the electric fields. Notice that the force is very similar. It's an inverse square law. Notice that the relationship here between the constants. Notice this is very small compared to this. 10 to the minus 11 versus 10 to the 9. Okay, notice that the gravitational field is gm over r squared and the electric field is kq over r squared. Both very similar in look. How are gravitational electric fields similar? A, they both increase the further away you get from the source. B, they both decrease by a factor of the square of the distance between the two masses or charges. C, the fields decrease as a factor of the distance between the masses and charges. D, the fields are constant throughout space. Go ahead and select your answer now. Okay, hopefully you chose the answer B. B is the correct answer. How are gravitational electric fields different? Select two answers. A, the gravitational field is much stronger than the electric field. B, masses in a gravitational field always feel a repulsive force, where charges in an electric field always feel an attractive force. C, masses in a gravitational field always feel an attractive force, where charges in an electric field feel either an attractive or repulsive force, depending on their polarity. And D, the gravitational field is much weaker than the electric field. Go ahead and pause the video if you need to and select the correct answers. Remember, you need two. Okay, so let's see if you chose the two correct answers. You should have chosen C and D. An electron is placed near a proton. Which field is mainly responsible for the attraction between the two particles? Is it A, gravitational, B, electric, C, nuclear, D, magnetic? Go ahead and pause the video if you need to. Okay, hopefully you chose B as the answer, the electric field. In the next video, we'll cover electric field of multiple charges.